Hey, Business 20 students, this is Mr. Doucette, and I am going to be working out some of the problems and explaining a little bit about what Chapter 10 is about. This is simple interest, and it's fairly simple, and it's obviously very important in business because when it comes to investments or it comes to loans, which is also very much part of our everyday life, you're going to pay interest or you're going to get interest based on various variables within, the terms in which you've agreed to either borrow that money or to invest that money. And so we're going to be solving all kinds of problems that deal with interest. And then next chapter, chapter 11, I'll do a separate video on explaining how to use the tables in your book for compound interest. But kind of to give you a baseline of this, of course, you have what we called up to this point our portion formula. If you remember, we had our base, we had our portion, and then we had our rate. And this little formula kind of looked like that, where you had the vertical line was multiplication and the horizontal line was division. And this, any number of, this was to help us find percentages. And of course, we would be able to find those percentages by either multiplying, dividing two of these three factors that we were using at the time. And now we're going to introduce a little bit different formula, but very similar to the one that we were using. And this one we're going to call the interest formula. And it kind of looks like this, but there's actually one other category now. Instead of two, there's now three. And this is going to be interest. This is going to be principal. In other words, how much you've borrowed or how much you've invested. This is going to be the rate. And then this is going to be time. Because obviously interest accumulates over time. And this is what you might call the simple interest formula. And you can solve all of the problems in Chapter 10 using this particular formula. Everything on the bottom of the horizontal line, you multiply together. Everything on top of the horizontal line, you divide. And if you have two of these four or three of these four factors, you can solve any of the problems that are in this chapter. And of course, they are going to be giving you at least three of those variables for you to work with in order for you to be able to solve these problems. So what I'm going to do is I'm going to solve some of these problems, and I'm opening my book to chapter 10, page 306. And in here we have a couple of problems under example 1 that I'm going to go over. Now there's an example 1 is actually explained for you. So I'm going to go to the try it exercises. And we have a problem that is telling us that we have $4,000 of principal. So I'm going to put 4,000. And I have a rate of 7%. And I have a time period of 2 1/4 years. Now, and these are all going to be multiplied together. And what I'm looking for is my interest. What is the interest on that particular investment or that particular loan? And the way you draw that out is we would just do the 4,000 times 0.07 times, and it's, what did they say, 2.5 years or 2 1/4 years, which would equal to 24, 25, 27 months. So I would do 27. Now you can do all of the time pieces in different fashions. You can do it annual, which is obviously yearly. In that case, it would just be 1. Or you could do it monthly, which would be always divided by 12. And then you can also do it daily. Did I spell daily right? And daily would be divided by either what's called ordinary interest, 360 days, or divided by exact interest, which is 365 days. The way to understand the difference in those two is ordinary starts with an O, and that's 360. So that's the way I've always remembered it. And then exact interest is exactly how many days are there in a year, and that would be the 365. And so I'm going to work this problem out. I'm going to start all over here and work out this problem for you. So 4,000. So again, we have 4,000 by 7%, and by 27 months is what I said. And then then we're looking for the interest. So we're going to do the math on this. Times 0.07 times 27 over 12. I'm going to do the math. I'll be right back. I'm going to do it just as I've written it here. I'm going to type in my calculator 4,000 times 0.07 times 27 divided by 12 equals, and it came up with 630. And that is our answer. So the interest paid on that particular loan is $630 over that period of time. So I solved that problem. On to the next one. All right, the next problem has a principal of $45,000 at a rate of 9.75% divided by 3 months. And what we're trying to find here again is the interest. So I'm going to take my 45,000, times 0.934. And I'm going to, or actually 975 times 3 over 12. Do the math. I'll be right back. So we have 45,000 times 0.0975, because that's what 9.75 would be, and then times that by 3 equals 12 equals $1,096.87. So I'd round that to 88 cents. So that's my answer, $1,096.88. And that would be the interest on $45,000 at 9.75% interest for 3 months. So this is again called simple interest. All right, last question that we're given here in this book is 130,000. So again, I'm just going to keep using this because it's going to be kind of handy later on. 130,000 divided by 10.4%, and the period of that interest or loan is 42 months. And again, I'm looking for the interest. So I would take my 130,000. I don't even have to write that out. I should just do it. I'll just do it right inside the formula. 130,000 times 0.104 times 42 divided by 12 equals 47,000. So the interest on this one is $47,320 of interest, and or whether that interest you pay or interest that you get added if it's an investment, it's the same, $47,320. So on $130,000 for a 10.4% interest rate for 42 months would give you $47,320. That's how much interest you've earned. So that's pretty nice. We don't see loans or investments for 10% any longer, but that was something that we had done before. So in the past, but not anymore. Now they're more like 2%. Anyway, we'll move on to some other questions here. All right, the next problem I'm going to look at has to do with dealing with days of interest. So far, we looked at months and years. Now we're going to look at days, and this is found in page 307, example number 2. Try exercise number 2. And remember, I said there was 2 different ways. There was ordinary interest method, and that was 360 days. And then there was exact interest method, and that equals 365 days. So the question here, page 307, example 2, try exercise 2, says Joe Hale goes to a credit union and he borrows $23,000 at an interest rate of 8% for 119 days using the exact interest method. So we're going to do 365. So in order to find how much interest Joe paid on his loan, we need to take the 23,000, multiply it by the 8%, 0.08, multiply that by the 119 days, divided by the exact interest method, 365, equals $599.89. So that's how much interest he paid after 119 days on that particular loan. So that's not too great, is it? So that's using the ordinary or exact interest method. Then if we jump down to problem number 3, in example 3, try it exercise number 3, it says Karen Mitroff goes to the bank and borrows $15,000. So 15,000 at 9.5% interest for 250 days. And they want us to use the ordinary interest method, which is 360. So I'm just going to do the math, 15,000 times 0.0950, because that's the interest rate put in the decimal form, times 250 divided by 360 equals $989.58. So that is how much interest she paid on that loan that she took out. So this is, again, using the days, using the months, using the years. On chapter 10-3, it's next gets into calculating the maturity value of a loan. And the maturity value would basically be, if you took, in this case, the 15,000 and you added the interest, which is 989.58, the result of that would be your maturity value. How much is your new principal after you added the interest, or how much is your new investment worth now that you've added that interest to it? So that's what the maturity value is going to look at. And there's a couple of ways that you can do this a little more quickly. So I'm going to show you that. All right, if there was a little delay there, I got disconnected, so I am back. And this is what we call the maturity value formula. And so it's principal times 1 plus the rate times time, and that'll give you the maturity value. So basically by putting that 1 in there, you're adding the principal back in to the final product of the investment that you're making. So we're going to go back to chapter 10. And I was in chapter 10, section 10.3. And we had a question here that, and there's kind of 2 ways you can do this. I'm going to do it the old-fashioned way first, and then I'm going to do it the new way using this formula. So using the old formula, we'll start with that. We're going to go back to this one, which is the, in this case, it's going to be the interest up here, and then the principal, the rate, and the time. So the problem says that this is try exercise 4 on page 308. It says the maturity value of a loan is $15,400. The rate is 6.5%, and the time is 24 months. So I'm going to do the math on that one, and I'm going to get my interest first. And then I'm going to do it the other way to show you that it's done twice. So 15,400 times 0.0650, that's 6.5% in decimal, times 24 divided by 12 equals. So that equals $2,002 of interest. So for $15,400 at 6.5% interest for 24 months, I'm going to earn $2,002 of interest. Now, if I wanted to do that all in one fell swoop, I'm going to do the other formula. This is going to be my maturity value. I'm going to do principal plus 1 plus rate, and then I'm going to do time. So I'm going to use the same problem, 15,400. I'm going to do 1 plus 0.0650, and then I'm going to do the time, which is 24 divided by 12. Now, when you're doing this problem, because it's 1 plus 0.0650, is you want to start from the innermost circle. So 0.0650 times 24 divided by 12 equals, so the answer to these two is 0.13, and then I'm going to add the 1 back into it. So then I'm going to multiply 15,400 by 15,400 times 1.13, and that should equal 7402. So if you take my 15,400 here and you multiply it or add it to 2002, you get $17,402. It's the same price. So all I did was I added the 1 here, and I called that maturity value versus interest. So the rest of the problems you can solve using either of the formulas. If you want to do the long math and add the interest once you figured it out, that's probably the easier way. But you can also do it this way. Let's do one more problem. This is try exercise 4B. What I was just doing was try exercise 4A. So try exercise 4B says Air Apollo Taxi Service borrowed $450,000. So $450,000. And they got a rate of 8% for 9 months. So they want to know, to purchase a new airplane, use the formula to find the maturity value of the loan. So in this case, we're going to start again with the innermost circles. We're going to go to 0.08 times 9 divided by 12 equals 0.06. And then I'm going to add plus 1 to that. And then I'm going to multiply that by 450,000. So 450,000 times 1.06 equals 477,000. That's your answer. That's how much the maturity value of this is going to be. They're going to put money in for 450,000, 8% interest for 9 months, and they're going to have 477,000 at the end of that 9 months. So that's how to use the maturity value formula in figuring the loan itself. And let's see. Sections 10.5 and 10.4 deal with dates. All I got to say there is just need to add your dates to know how many days to add or how many days to subtract. It's very similar to figuring out the maturity date of your trade discount or your cash discount. So I'm not going to cover those any longer, but I am going to go to 10.6, which is basically using this principle that this formula that I just gave you. So I'm going to come back to that. Okay, now we're going to get into 10.6 and 10.7, and these begin to solve for other factors within that formula. So again, to give you the formula, principal, rate, time, interest. Now we're going to figure out how to solve for some of the other factors when we have the interest. So for instance, 10-6 is solving for principal. So we're solving for this one here. And in order to do that, it's the same way we've been doing it. Remember, this is multiplication and this is division. So in this case, this is example 7, try exercise 7 on page 314. Telex Electronics borrowed money at 9% interest. So we're trying to find this factor here, 9% interest over 125 days using the ordinary method, so divided by 360, and they had an interest of $560. All right, so we're trying to find that factor right there. So what we would do, of course, is first multiply 0.09 times 125 divided by 360. So I'll do the math on that. 0.09 times 125 divided by 360. We use ordinary method. Came up to 0.3125. Now I'm going to divide 560, which is the interest, by, because remember this line means divide. I'm going to divide that by 0.3125. And that gives me $1,792. That is my principal. So on this particular thing, the interest was 560. Calculate the amount of principal of the loan. So the principal of the loan was $1,792, and I paid $560 of interest after 125 days. So that's the answer to that problem. All right. The next one is solving for rate. So in the same way that I just did that problem, if I move on to the next one, this one says using the ordinary interest method, find the rate of the interest on the loan of $25,000. So we have the principal. After 245 days, we know that, and this is using the ordinary interest method, so 360. What we're trying to find is rate. And we did find the interest. The interest was $1,960. Again, this is Try it exercise 8 on 315. So again, I don't have rate. I don't know what that is, but I have the 3 other factors. So I'm going to take my 25,000. Oops. I'm going to multiply that by 245 divided by 360 equals 17,013,889. I recommend, by the way, that you use all of that when you're doing the division. So you're going to divide that by 1,960. So you're going to go 1960 divided by 17,013.8889 equals 0.1152. So that comes out to 11.5%. So that was the rate, 111.5%. Let me check my answer on page 334. I don't know if that's the same page on your book, but 334 to question number 8 is 11.52%. So I was correct. All right, so that's solving for rate. That's solving for principal, all using this formula. The last one is solving for time. So again, we're going to do the same thing. This time we're going to solve for this one here. And the problem that we're given in example number 8, try it exercise number 9. Excuse me, example number 9, try it exercise number 9, page 316. Says, what is the time period for a loan of $15,000? Make sure my cat's still around. At 9.5% interest, looking for time, with an interest, ordinary interest of $650. So remember, it's going to be ordinary interest, so it's going to be 360. We'll come back to that. So again, we're just going to do the math. 15,000 times 0.0950. We're going to divide all that by 650. All right, let me do the math. So that equals 14,000. Oops, sorry, 1,400. $25. So 650 divided by 1420 equals 0.45. And then we need to multiply that by basically 457,4,6,48. I'm just going to write the whole thing out. And I'm going to multiply that by 360. And that equals 164.79. So that's not money, that's days. So that's how much time it is. It's 164, or you could just say 165 days to round it up. So 165 days. So let's check our answer, page 334, number 9. Is 165 days. Got it right. All right, so that's calculating, using this interest formula to find principal, to find interest, to find rate, and to find time. And the last thing you have is calculating loans involving partial payments. And this becomes a little tricky. I'll come back to that in just a minute. All right, this is the last problem that you need to worry about because we're not doing anything with promissory notes. This is the last problem in chapter 10, the kind of problem. This is one where you're going to be working with partial payments for your investments. So this one is try it exercise 10 on page 318. Rita Peterson borrowed $15,000. I'm just going to write down all the factors first. At 12%. Using ordinary interest for 100 days, ordinary 100 days. On the 20th day, she made a partial payment of $4,000. And then on day 60, she made another partial payment of $5,000. What was the maturity value of the loan? Wish I could draw this smaller. All right, so the first thing we need to figure out is how much interest did she accumulate up to day 20, right? So in this case, you're going to take your 15,000. You're going to multiply by the interest rate, so 0.12. And then you're going to multiply that by 20 by 360, right? That's going to give me my interest for the first period. So 15,000 times 0.12, that's 12%, times 20 divided by 360 equals. So it's going to be 100. So she had $100 of interest. So what they like us to do is to minus that from your payment. So minus 100 equals 3,900. So I'm going to minus the 3,900 from my original principal. That's going to give me, let's do it the fast way, 15,000 minus 3,900 equals 11,000. Equals $11,100. All right, that's now my new balance. So $11,100 times 12% again. And this time the next payment is day 60. So that means that another 40 days have passed, right? So that's going to be 40 days times 360. That's going to give me my new interest amount. So 11,100 times 0.12 times 40 divided by 360 equals $148. So I'm going to minus that from the 5,000. So that's $4,852. That's going to come off my 11,000 and give me a new balance. So 11,100 minus the 4,852 equals $6,248 times 0.12 times. Now there was 100 days in here. We used 60, so there's 40 more to the end of the maturity. So that would be my last mathematical calculation. Times 40 divided by 360 equals 6248 times 0.12 times 40 divided by 360 equals $83.30 interest, actually 31 cents interest. So I would add that to the $6,248. There's no change, huh? So 83 plus 6,248 equals, so my maturity value was $6,331.31. That was the maturity value of that particular loan after all those payments were made. So that's how much I owed at the end, 63. Let me check my answers. Yep, 63. So final payment due was 63.31.31. That's what I came up with. So anyway, that's doing the partial payment. Just remember when you do the partial payment you have to take the interest for the period before the partial payment is made and then subtract that from the partial payment because that's interest that was added. And you do that each time until you get to the last one. And then you add the last amount of interest to the existing principal, and that gives you your maturity value. So hopefully that was helpful. I'm going to be splicing together a couple of videos when I do this because I had some technical problems, but this is a start. So hopefully it's helpful to you. Have a great week, and I'll be moving on to compound interest next. Have a great week. Bye.